Hi everyone, thanks for coming back to the channel. If you are new guys, please don't forget to subscribe. Today we are just doing trigonometry part, the trigonometry part of a question paper. This is just the general trigonometry. It will be with the exclusion of trig functions and the 3D shapes. Okay, the first question, I'm told that if sine 33 is equal to m, I'm told that sine of 33 degrees is equal to m. Determine the following in terms of m without the use of a calculator. If I'm asked to determine something without the use of a calculator, I should always use an aid of a diagram. Always the time. If I have 33 here, simply means that on the other side I'll have 57 degrees. Why? Because I have a right angle triangle. Altogether, the sine of 33 degrees is equal to m. So this is the same as m all over 1. So whenever they are giving me the sine of 33 degrees, they are telling me that the opposite side to the angle of 33 is equal to m, and then the hypotenuse is 1. I can only find the adjacent side by using the Pythagoras theorem. I'll simply say x squared is equal to r squared minus y squared. My r squared is 1, my y squared is m. This is equal to x squared. Therefore, x is equal to the square root of 1 minus m squared, right? So whenever I see x, I'll just substitute the square roots of 1 minus m squared. So since I have the values of x, y, and r, I can answer everything. I know that my x value is 1 minus m squared, the value of y is m, and the value of r is 1. They want me to find the tan of 33 degrees. By definition, tan is opposite over adjacent, or just y over x. So tan of 33 degrees is equal to m all over the square root of 1 minus m squared. Are we together? Okay, now I have the cos of 777. The minute I have angles which are larger than 360, all I need to do is to just subtract 360 until my angle becomes smaller than 360. Are we together? When I take 777, subtract 360, I'll get 417, which is still greater than 360. I need to subtract 360 as well. Then I'll get 57. They want me to find the cos of 57 degrees. Cos 777 degrees is equal to the cos of 57. I go to my right angle triangle. By definition, cos is adjacent over hypotenuse. The side which is adjacent to 57 degrees is m, and my hypotenuse just stay the same, is m all over 1, which will just give me m. And then they want me to find the sine of negative 237. Whenever I see negative angles, I need to add 360 this time. So I have 237, right? So all I have to do is to say 360 minus, or it's negative 237. I'm going to add a 360 to it, and then I'll get what? 123 degrees. This is the same as the sine of 123, right? 123 is an angle in the second quadrant. In the second quadrant, we write our angles as 180 minus something, which will give me 23, and that something is 57 degrees. So sine is positive in the second quadrant, so I'll simply have the sine of 57 degrees. Sine of 57 degrees, I go to my right angle triangle. There is 57. Which side is opposite 57? Is the square root of 1 minus m squared all over 1. So this will be the sign of negative 237. Okay, and now I'm told that 4 tan beta plus 5 is equal to 0, where beta is an angle which is found in the between the first and second quadrant. né? Determine with an aid of a diagram without a use of a calculator the value of the square root of 41 plus cos beta. Okay, here you are going to use the method called take and draw. né? Since we are given 4 tan beta, this thing can be written as negative 5 over 4. When I take the 5 to the other side, it will be negative. Then I'll divide both sides by 4. I'll have negative 5 over 4. né? Okay. Firstly, I have tan of angle beta equal to a negative number. I must go and tick on the quadrants where tan is negative. Tan is negative in the second and fourth quadrant. Are we together? But we are restricted in where we can find the angle of beta. The angle of beta can be found between 0 and 180. My right angle triangle will be always where I have the most number of ticks. Are we together? So I have the most number of ticks in the second quadrant. So that means I have my angle of beta there. By definition, tan is opposite over adjacent, right? So this will be positive 5 because our triangle is above the x-axis, but this one will be negative 4 because our triangle is on the left hand side of the y-axis, right? When you divide the two, we'll get a negative answer. Then all we need to find now is the hypotenuse. How can you find the hypotenuse? By using the Pythagoras theorem. R squared is equal to x squared plus y squared, right? So our x squared is negative 4x. R is 20. R is equal to 5 squared. So this thing will give me 41, and then R will be the square root of 41. Are you together? So now I know that my radius here is equal to the square root of 41. And then all I need to do is to find the value of the square root of 41 multiplied by cos beta. Remember that cos beta is always adjacent over hypotenuse. So this is negative 4 all over the hypotenuse to the square root of 41. And then these two will cancel. I'll be left with negative 4. So the answer for this is just negative 4. And you get your full 4 marks. Okay. Now I'm asked to simplify the following expression to a single trig ratio. The first thing, guys, I need to do whenever I simplify is to reduce all of my angles, right? But before I do that, I must just build the structure first. I have a negative 1 there. Okay, let's go. 180 minus is an angle in the second quadrant and sign is positive there. So I'll simply write the sign of beta, right? And then I have cos of 90 minus beta. Whenever I see 90 minus, that means I must change to the co-ratio. But 90 minus is in the first quadrant, so I don't have to worry about the signs because I know that everything is positive there. So I'll simply just change this thing into sine beta, and I still have the minus 1 there. Are you together? Uh, Negative angles are angles in the fourth quadrant, especially if it's just a negative unknown variable, negative beta, negative theta, negative x, alpha, and so forth. Those angles are angles in the fourth quadrant, right? So in the fourth quadrant, I know that cos is positive. So I'll simply write cos of angle beta. And then now I have sine squared beta minus 1 all over cos beta, right? I can take out a negative there at the top, and then I will be left with a positive 1 minus sine squared beta. Add together, and then I'll be left cos beta at the top. Then this thing will give me a negative cos squared beta all over cos beta. So this will be just be equal to a negative cos beta. So this thing is equal to a negative cos beta. All right, together. The first thing you need to do is to reduce your angles. After reducing angles, check whether there are two things you can change into one. That means you must refer to your square identities. Then the third step is to change everything into one trig ratio. And then after doing that, you'll keep on repeating step number 2 and 3 until you get to your final answer. If you are struggling, guys, please go to the first. There is a link on the description. It lays out the playlist for trigonometry. If you are struggling with understanding how to simplify, please go click the first video on trigonometry. You will be fine. Okay, now they say hence determine the values of b, or determine for which values of b where b is an angle in between 0 and 360, such that the expression will be undefined. This expression will be undefined if my denominator is equal to 0. Are you together? And if this thing is equal to 0, I know that cos of beta is equal to what? Cos of negative beta is in the fourth quadrant, right? So I'll simply say cos of beta is 0. So I'm supposed to find a general solution for this thing. All I need to do is to say reference angle is equal to the cos inverse of 0, which is 0. Are you together? So this thing, beta is just 0 plus k is 360, where k is an element of integers. Then if I'm given a restriction like this, that means I must find the actual values of beta. How can I do so? I can just substitute the values of k, because k represent integers, right? So the first thing I'll do is just substitute the first integer whenever I see k. So the first angle I get is 0. Okay, another one, another integer I should put is 1. Okay, whenever I substitute 1, I get an angle of 360, which is still in this restriction. Let me see, what do I get whenever I substitute 2? I get 270, so I don't need to go further. Let me go to the negatives. Negative 360 is not within the restriction, so these are my only two answers. Are we together? Okay. And then I'm supposed to prove the following identity. I'm going to simplify the left hand side because it's the most complicated side, right? for me to work easier here, I must always change everything into sine and cos. Tan can be written as sine alpha over cos alpha, right? And then this thing is still multiplied to sine alpha plus cos alpha. Right, together, and then I'll have sine squared alpha over cos alpha plus cos alpha. Whenever I have fractions, I must just get my LCD and then add the fractions. The LCD is cos A. This will give me sine squared A plus cos squared A, right? Sine squared plus cos squared is 1. So this is 1 over cos A. Now I've proven that the left hand side is equal to the right hand side. Are we together? Okay. And then the follow-up question says, hence show that this thing, hence determine the general solution of these two things, right? Okay, how can I do that? I know that this side can be equated to this side because I've just proven the identity that they are equal, right? So whenever I see the left hand side, I can simply substitute to the right hand side and have what? And have cos, excuse me, Norman is equal to 3 sine A. What I can do here to make my life simpler, because I cannot change everything to have 1/3 ratio, I can just multiply both sides by sine alpha so that I can have tan. Sine alpha. Then I'll have sine over cos this side, which will give me the tan of alpha. Here the signs will cancel. I'll have 3 right together. The first thing I do whenever I determine the general solution is to find the reference angle. The reference angle is tan inverse of 3. What do I get? Shift tan 3. I'll get 71.57 degrees right together. For tan, guys, it's just simple. You can only express your reference angle in the first or second quadrant, right? So if tan is equal to a positive number, then you must express your reference angle in the first quadrant. If tan is equal to a negative number, just express your reference angle in the second quadrant. So in this case, I'll simply say, therefore, alpha is equal to 71.57 degrees plus k 180, where k is an element of integers. So this is how, guys, you tackle trigonometry questions. I hope this video, guys, was fruitful. Please, guys, stay tuned and wait for more videos. Thank you.